Hey guys, good morning all of you. So in this module we will be discussing about Wheatstone bridge. So what exactly is the Wheatstone bridge and why do we use it most often in the electronic circuits? This is very important concept and it is also widely used in various measuring instrument and other instruments on board ship as well as in industrial arena. So we must know as an engineer what Wheatstone bridge is and how does it work. So let's begin.
Hello ETO aspirants, Jai Hind, Jai Bharat, Jai Mata Di. If you want right information, right guidance, download Merchant Navy Start app right now. If you are looking for online recorded classes or online content from where you want to study, go for ETO Aspirant Excellence Package on Merchant Navy Decoded. What are you waiting for? Jai Hind, Jai Bharat, Jai Mata Di. The link is in the description box. Take care, bye.
So what you see in front of you is the construction of a Wheatstone bridge. So you please pause the video and just try to understand how the construction is there and how the placement of resistances are there and what is this in between. Okay, so let's begin. So first of all, when we talk about a bridge, so here is the placement of these 4 resistances across each arm AB, BC, CD and AD. There are 4 resistances. 2 of these nodes here or junctions, they are provided from a DC source, that is battery, and across the other nodes, that is junction B and D, they are joined together through this galvanometer, which is there to read the current value in this arm. B and D, whatever current is flowing, my galvanometer is going to read that. Okay. So this Wheatstone bridge is basically named after Mr. Charles Wheatstone because he basically improved this bridge a lot. And why are we using such an arrangement is because this is very sensitive equipment and it can measure changes in the resistance very effectively. Means if there is any change in the resistance in these arms, then we can get a deflection at the galvanometer. Okay, so having said that, let's understand what do we mean by a balanced Wheatstone bridge. So when can we say that this Wheatstone bridge is balanced? So first of all, we need to know the resistance values. Let's say this resistance value is P, this is R, this is Q and this is S. This arrow suggests that this is variable resistance. We can simply vary the resistance value here. Why do we need to do that? Because if we vary this resistance, we can actually make this Wheatstone bridge and we can convert it into balanced state. Okay, so for that we need to take a ratio first. So when we say it is balanced, that time the ratio of resistance is P over R should be equal to Q over S. Or you can also write P over Q equal to R over S, because you can simply bring the Q here and bring the R there. So it's the same thing, either this over this is equal to this over this, or this over this is equal to this over this. So you don't need to remember also, right? Okay, so when this is the condition, when this ratio is equal to this ratio, at that time there will be no current flowing through this arm. If there is no current flowing through this arm, that means galvanometer is showing me 0 deflection. That also means if there is no current flowing, that means the potential at B, VB, and here let's say the potential at D, when there is no current flowing, that basically means the potential had to be same. That's why there is no current flowing. So in that case we can say that VB is equal to Vd. So potential at B is same as potential at D. So basically we can say that potential difference between B and D is 0. There is no difference in potential because they are same. The potential may be there, but since they are same, so there is no difference. When there is no potential difference, the current will not flow in this arm. Now, if we change any of these resistances, any of these, let's say the resistance in question is this. Initially the bridge is balanced. If it was not balanced, we can make it balanced by just changing the value of S, and we made it balanced. Now after that, if there is any change in the value of Q or any one, let's say we are only focusing on Q, then there will be deflection because it is no more balanced. So when can Q change? We will see that. Means what all factors is affecting my resistance here? I can measure that through change in the deflection here. So if my resistance change, I'll get to know. Simple. So that's the application of Wheatstone bridge. Wheatstone bridge is very sensitive equipment. Basically it will tell you if there is any change in resistance value, we will get to know through Wheatstone bridge. So what is an application? Let's see. So there are just few applications which we have listed. There are much more than that. So basically used in measurement of temperature. What do we use for measuring temperature? We use a sensor called PT100 on ships and in industries also. Secondly, we can also measure torque or shaft power in what equipment? Torsion meter. And also we can get to know how much is the hydrocarbon percentages. There are certain area on ships where there could be a possibility of hydrocarbon gas, and that can be dangerous. So we must monitor those areas. So for that reason we are using an equipment called explosive meter, which basically is measuring hydrocarbon percentages. We are using Wheatstone bridge in the circuitry of that explosive meter. So these are few basic uses. We are going to explain that in details in the later sections or later modules. So that's all for here, gentlemen. See you again next time. Bye bye.